Hey there, friends. It has been again. This is a video for the math tech class. This is for day number 11, where we're going to look at some computer algebra systems. The video may seem to feel a little bit scattered because we've got multiple things to run through. And I'm going to try to give you a pretty good idea of what to do. Okay. So with that in mind, let me share my screen and we will get going. And that, okay, I think I can share that. Okay, so that should be showing you what's going on my desktop here. And notice that you have this page and it tells you exactly what to do. So if you don't want to watch the video because it's kind of slow and my jokes aren't that funny, you can go directly to that and you can probably get through this faster, okay? But as we go along here, we'll do the check-in. I do not have the video linked in because I'm still making the video. But you will need to create a Google Doc. There's a link to one. Here's what the Google Doc looks like. It leaves space in there for you to put stuff in. And where your name, it says your name here. If you, come on. If you go ahead and highlight that, type your name, blah, blah, blah. And, you know, come up here to the name of the file and change that to something that has your name in it, okay? But you will have to do that after you make a copy because I have set this to be just view so you don't all have the same document, okay? So anyway, though, make a copy, put your name in there, okay? And then we will go to the second step here, which is about graphing and solving an equation with Colab. So the Colab file talks to you a little bit about a package called SymPy. I say SymPy because I talk funny. So yeah. In any case, though, if you run down through here, you'll see explanations and stuff, but there is a package called SymPy, and we're going to tell it to just import everything from it. You have to run this. If you don't run it, the rest of the package won't work. So, you know, the rest of the notebook won't work is what I mean. So I'm going to go ahead and run that. And notice it didn't do anything, but it loaded up all this stuff from SymPy. And then it does this magical thing of making X into a symbol. Now that probably doesn't register on you because you've dealt with a little bit of algebra and you're like, oh yeah, X is this thing, we don't know what it is. But computers cannot handle that at all. You say X and it's like, X what? And it wants to know a number, otherwise it won't do anything with it. But somehow, magically, this will make it treat that X as a symbol. And I don't understand how it works. But then once you've got that, SymPy has a few things built into it, like a function that will expand things. So if you told it, for instance, here to take x minus 2 times x plus 4 and to multiply it out, it will FOIL it and it will collect the answer in there and get you this x squared plus 2x minus 8. And it knows how to do that sort of thing. Similarly, you've got something called factor, which will, I think you can guess, factor for you. And if you give it an expression that's factorable, it will do its best to factor it down into linear and quadratic terms. So this one here was a cubic, and as you might remember from an algebra class, cubics are just hard to factor. So if you can figure them out, great. And when you can't, you just can't. So anyway, this will go ahead and factor something if it can be factored. And then I want to show you this thing here. Now, remember earlier, that we had this x squared minus 2x minus 8 that came out of multiplying some things together. Now, if you wanted to take that x squared minus 2x minus 8 and set it equal to 0, you can't set it equal to anything else. It has to be equal to 0, okay? But you can tell it to take, trying to highlight just this part inside here. You can tell it, here's the thing I want to set equal to 0. And then you tell it that you want to solve for x. And because we're using this function here called solve set, it will actually give you a set of all the possible x values that would satisfy that equation. And so this turns out to have -2 and 4 as solutions there. And it like hid all of the good stuff for doing that. If you were really working that out, you ought to have to take that and factor it, set each factor equal to 0, and so forth. But, you know, this is a time saver. All right, so then we're also going to take just a brief look here at how SymPy does plotting. So we've done some stuff with Matplotlib already, but this thing, if you just tell it, here's my function. Actually, I should erase that. Here's my function, and I want you to plot it. You don't tell it anything else, it will try to plot it for you. And by default, if you don't tell it what to do, it will plot for your x values going -10 to 10. For the function I picked out, that's kind of bad values to do. Okay, and that's just because the value of x cubed gets really big in there. So you know you've got stuff going out to 1,000 and stuff. So if instead you wanted to plot things, and I need to delete that. If you wanted to plot things with the x values just going from -3 to 3, then you would do that like so, okay? And so I'm going to plot that, and you'll notice that it's got the same basic shape, but now you can spot that -2 and 2 and 0 are all places that it's like intersecting the x-axis at. There's a way to do this and cut off y values as well, but you've got to do a little bit more with it, okay? So your first problem here is to plot that 2x cubed plus, I'm sorry, 2x to the 4th plus 2x cubed minus 4x squared. So you'll come along here and you will say plot 2 times x to the power 4 plus 2 times x to the power 3 minus, I really wish the damn thing would quit trying to help me. It constantly pops up stuff that blocks off what I'm trying to look at. 4 times x to the power 2. You hit Command Enter and boom, it plots it for you, okay? But that plot is crap, right? It just blows it up. So if you stop there, you don't have a very good plot. So I'm gonna go in here and I'm gonna say, well, I think maybe if I went from -5 to 5, I could see this better. And then I look and I go, nope, looks like I'm still not really seeing it better. Maybe I could put that -5 to 2. Yeah, no, I think I'm gonna have to go like maybe -3 to 2. Notice I'm just going through and doing this over and over again, right? I'm just changing it. You can totally do that. It's not a big deal. And now I've got a plot of it that, I think it looks all right. So, no, I want to go from 2.5 to 2. And maybe instead of 2, I'll go to 1.5. I'm just trying to narrow in. I kind of know what the final answer is supposed to look like, okay? Now you get that picture there, and if you right-click on it, I don't know if you can see my pop-up menu, but it has copy image as an option. I'm going to come over here on my Colab portion. I'm going to right-click, and I'm going to paste. Now I'm going to get that picture. And you can take that picture and you can make it smaller. Okay, Let me reload that. Well, then let me undo that because that was bad. Okay, I'm going to paste a new version of it because that looked bad. All right, so I'll paste it in there. Apparently changing the size kind of goofs it up, right? All right, let's go back to what we were doing, right? The problem number 2 said to use the ideas in the preceding to factor that. All right, well, it seems like we did something about factoring 2 times. Oh man, stupid thing's gonna go up there. I'm gonna tell it to factor stuff, but I'm just gonna copy and paste the same thing because, you know, and then command enter and it factors it. And I'm going to see whether I can copy that and paste that over. And I probably should put more. Oh, pasting it over, it doesn't look very good, right? It made it put it on separate lines and stuff. But if I go back there and zoom in, I can highlight that too. And let's see, format, text, superscript. If you're saying, gosh, how would I know how to do that? It's word processing stuff. It's fairly normal things for people to be dealing with. But here I'm going to say factored. And then I'm going to go back. Oh, no. I'm going to go back to the day 10 stuff. And the third problem it asked us to do was to solve for that stuff equal to 0. All right. Well, I'm going to come up here and actually just, come on, copy that line. I'm going to put it down here. And I'm just going to change where it says factor into solve. Now, do you remember how this went? That you would say solve, and then you'd have your polynomial, and then a comma, and then an X to tell it to solve. Oh no, I did it wrong. Do y'all remember? I didn't say solve, it was supposed to be solve set to get a solution set. Okay, -2, 0, and 1. So now I'm going to copy those. I'm going to pop back over here, and I'm going to say roots and put those in there. Now, if you look back up at the graph, you can see that it's crossing the x-axis at -2, 0, and 1. It's almost as though we had a little algebra lesson here, right? All right, so anyway, so there's also a little bit in here that talks to you about that you can get this to do some calculus for you. It will differentiate some stuff, and it will factor things that have exponentials in them. And you can even combine those things together and tell it to factor something you differentiated and then do the solve set thing. So it's actually pretty cool. So anyway, so a computer algebra system, there's many different computer algebra systems out there, but this one called SymPy within Colab is something you have access to for free, and it can do some of your work for you. So that's the thing we're going on to with that. Let me jump back to the assignment part here, where, you know, I said before, you would click and open the Colab notebook, and of course you'll have to make a copy of it so you can edit it. But this next thing is something called Desmos. A lot of you have dealt with Desmos before because it's a website that graphs functions, and it does the best damn graphs. I mean, really. Take a look right there. So I have this function in here, f of x equals blah, 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 you know, stuff like that. And I put this a in there. Let's see if I can highlight that. And the reason I put that a in there was to show you what you can do when you put in something that's not an x. it will pop up and say, hey, do you want this to be a slider? And I did. And once I got that to be a slider, I can take and change the value of A and it will update it immediately. Holy smokes, right? And the neat thing is, I got zoomed in too much. The neat thing is, if I want to see where this graph intersects the x-axis or the y-axis, I can just click on it. If I want to see where the maximum is or the minimum is, I can just click on them, okay? But for the assignment of what we're looking at, we have a particular one we want to do. It says x squared e to the x, all right? So we're going to come along in here and we're going to add a new one, g of x. Now see how it wanted a slider there? We don't want a slider for g of x. We want that to be our function name. G of x equals x squared e to the x, okay? And, oh, I didn't remember it right. It was supposed to have a C at the beginning, C. So we'll tell it to add a slider for C. And I'm going to just turn that function f off. And then I'm going to zoom in on this where you can see it pretty good. App, come on. Nope. Sorry, it was zooming kind of weird there. And notice I can go ahead and just click on those. And then when you've got this slider and it changes, those points will go away, all right? But there's a neat aspect of this here. If you notice, that maximum is, after you've tried it a few times, is always showing up right on top of the x equals 2. So here, I'm going to tell it the point, do the point 2 comma g of 2. I'm going to ask it to go ahead and label it. And, oh, actually, maybe not label it. Yeah. Okay. So, label, not label. Okay. Maybe not label. Well, that's weird. Turn it off, turn it back on, turn it on. Okay, and then my, swear to y'all, this worked the last time I dealt with it. So we get the point 2 g of 2. It does not like it. Okay, well, never mind. I thought it would allow me to just have that point there that would slide up and down, but apparently it's not working. Anyway, just get several C values that you identify, doesn't really matter what they are, and see what the Y values for the point turns out to be, okay? All right, once you have done that, let's see what the instructions ask us to do. Copy the resulting graph to Google Docs. Oh, no, sorry, that was the other part. Blah, 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 report on the maxima and paste the screenshot into the Google Doc. So insofar as a screenshot goes, I'm on a Mac, so I have a particular set of things that I can do with it. But if you're on a PC, you're going to have to figure out how to do something slightly different. For me, the weird hotkey combination is Command Shift 4. I do not know why they chose it like that, but once I've got that, I can click and drag across an area like that. To be kind of careful what I do. And I don't know if you could hear it, but there was a sound that was like an old-fashioned camera, and it made a file on my desktop that's called screenshot something or another. Okay, and so for this thing here in my Google document, I would like to insert a picture. Let's see, and image. And we're going to upload from our computer. I go to my desktop and I look for screenshot. Wow, looks like I've taken several screenshots and not erased them. Well, it's about 6:41, so it looks like that one's what we want. Yep, open, and it inserts it. Now, I am leery of changing the size because of what happened last time, but turns out this time it worked, okay? And then underneath that, I ought to put points that are maximums. Okay, I didn't actually go get the numbers, but you do need to go get the numbers. And so I'm just showing you what kinds of things that we're looking at doing. All right, so let's go back and see. And it also shows you, and this is a really cool trick, okay? Look for the share graph button on Desmos, and we're going to get the URL for our graph. So I'm going back to Desmos, and I am going to have to move a window out of the way. But here is our share graph button. It looks like the airdrop button for my Mac stuff. So seems kind of weird to me. But we click on it, and then we can hit the copy button and copy that link. And we could print or export image or embed. Those are all options to do here. But for what we want, we're going to come over here, and we're going to just say to this, a link to Desmos graph. And so then you take and highlight this, and we're going to insert a link. And the link, we will just paste that URL, tell it to apply. And now anybody can come in here and click on that and go to our graph. And that's pretty cool. It allows you to do a lot of neat stuff. So anyway, though, now we're going to take a look next at the SymboLab stuff, all right? So SymboLab is something that if you are in calculus is super useful, but if you're not in calculus, it has some capabilities that we've already seen in SymPy. It's just that it has a different interface, okay? So our thing we're going to ask it to do is to differentiate. That's something you do in calculus. If you don't know calculus, don't worry. It's just going to do it for you, okay? But differentiate this x squared e to the x. So come on. Zoom decided to block off the place I needed to click. All right. So hopefully that is where you all can see it. Okay, so it said I needed to differentiate, and that means I have to click that DDX button, okay? And then it said x squared. So to get the squared button, you shift 6, okay? So x squared, and then I'll arrow to get out of that, and then e to the x. So with SymboLab, it understands that putting things next to each other means multiply. So it will go ahead and treat those as multiplying. We will tell it to go, and it will give us a bunch of stuff. And here's the nice thing about this. And if you are taking calculus and you don't actually see how to do something, it will give you the steps. Now, if it's too many steps, sometimes it will just say, nope, I can't do it. And with my Calc 4 class, I bedeviled them with stuff that that they were like, okay, SymboLab just can't do it. And it was like the plus was in the wrong spot or something. It's weird. But this gives me what the answer is down here. And it also would let me, it also would let me show more steps as I need to and stuff. And I think that if I remember right, I think when I copy it, it's going to copy the answer better. I might be wrong about that. Oh, wait a minute. Oh, look at that. There's a copy button there. Let's go back and see if my derivative turned out okay here. Derivative is, I'm hitting Command V to paste. It doesn't look all that great. So I'm gonna take and mess with it a little bit. And you have to remember what it's doing a little bit. I have to highlight that X, format, text, superscript. Oh, that's command period. I didn't know that. Okay. I can highlight that and command period. And I can highlight that and command period. Okay. Now, what was the other part of the instructions? It's said on here to take the result and set it equal to 0 and solve. Okay. So going back to SymboLab, that answer that we got down there, the 2x, e to the x, and so forth, I'm going to copy it. And it didn't paste very well into Google Docs. It was okay, but it wasn't great. But if I go ahead and highlight this stuff here, and I'm going to tell it to solve for, and it goes ahead and shows me what the format is. Solve for x, and then a comma, and then the expression, and I want to set it equal to 0 and solve, which is a thing that we commonly do in calculus. And then I have to hit the go button again. And it will actually show me the factoring and so forth on this. But here at the end, it gives me my two answers of 0 and -2. And because this is the same thing we saw in Desmos, we know that that's actually the right place that it's turning out to be. And so I'm going to come in here and say the zeros are at x equals 0. I don't know why it has that weird smiley on it. And x equals -2. I'm going to put spaces in there so that you can read it better. Okay. So that's that. Now the Wolfram Alpha stuff. Let's see what our instructions were on that. It said to go to Wolfram Alpha and type in x⁻² and e to the x. So Wolfram Alpha has a slightly different notation and stuff. Okay. And maybe we also try then putting ddx in front of it. Wolfram Alpha is weird. Okay. It is connected to a computer algebra system called Mathematica that cost, okay, 15 years ago, it cost $1,200 per copy. So, it's a very expensive system, but it does lots of things and people use it in research. And Wolfram Alpha connects to that and does a lot of the things that you might want to do. And so I'm going to type in x² and e to the x. And I'm just going to see what it says. It has an AI that tries to guess what I want out of it. So it said that I input x² e to the x, and it thinks maybe I want a plot of it. And that plot does not zoom in very well. Yeah, that doesn't show me much. Okay. And so it didn't really feel like it helped me too much. It said that it has a root at x equals 0, and it did. We saw a graph of it a minute ago. But what happens if I go up here and say ddx of that? So that's the symbol that we used to mean take a derivative of it. See what it says. And it tells me what the derivative is. And it puts it in a slightly different format, but it's the same thing as what we got from SymboLab on there. And then it says, here's an alternate form of it. And I think that, one of these expanded or alternate forms was what SymboLab gave us. And then it goes ahead and figures out what the zeros are, okay? And then it tries to talk about some other things. Properties is a real function, range, a series expansion. If you know any calculus, this is like pretty wacky. It's looking where and finding the indefinite integral, and it's actually finding where the local maximum is, which is not quite what we were doing before, because this is finding the local maximum of the derivative, not the original function. So kind of weird. Takes a limit and does other things. It does kind of wacky stuff. So take a look at that stuff and type something about it. Then, actually, I should share screen and go back to that. Let me go back to that for a weird reason. Wolfram Alpha is meant to be something that is a little bit of a search engine too. If I say Greensboro, North Carolina, it will search the web and find out we have 296,710 people. And it finds us on a map, and it finds a map of the area here. I did not know we had that weird chunk cut out here in the western part of town. And look at that. So there's some sort of weird sectioning thing going on over here. This is probably the results of gerrymandering or something. But anyway, I shouldn't dwell on that too much. I'm just saying that Wolfram Alpha is weird. It turns up, wow, demographics, educational attainment, income statistics, and the cost of living and so forth. So yeah, Wolfram Alpha does math stuff, but it does other things too. So if you're researching something that you think might have numbers associated with it, take a look at Wolfram Alpha and just see if it does anything for you, okay? So that's kind of the end of my suggesting useful things to y'all. The next thing I'm wanting y'all to do is to find something to do. So remember that you have these conferences on Friday. Not very many people have signed up yet, but sign up with your partner. Please have partners, because you're setting things up for this final presentation on the last day. Now, let me say with that, we're going to have Monday and Tuesday as work days to prepare for that. If Wednesday is a bad day for you to have a final presentation, you can talk to me about the possibility of doing it on Tuesday. We can set something up. After you've done your presentation, you do not need to come to class. During work days, you do not need to come to class. You can just work on stuff. But if you need me, you need to, find a way to contact me or something. I set up that Slack thing at the beginning of the semester, and I have not done anything with it. So that might be a good way to try to contact me when I don't have Zoom turned on, okay? And then we'll try to figure out, a meeting from there. All right. So this particular assignment should go pretty quickly, all right? I will see y'all in class.